Okay, so now we are at question number 4. The question 4 reads this way. You start at rest and accelerate at a certain rate a for a distance d, and your final velocity is v. If you accelerate at 4a for a distance d, your final velocity will be what? So, kind of pictorially, you're going at a distance d, you're accelerating at a rate of a for a distance d, your final velocity is v. If you accelerate for the same distance, but 4a, 4 times the acceleration, okay, so it's the same distance, one is accelerating at a, one is accelerating 4 times as much. So what's going to be the velocity now? Is it going to be 4 times this? So the unsuspecting thinker or person might quickly put answer C, 4v. You have given here 4 choices, 2v, 3v, 4v, none of the above. So they're going to see this 4a, okay, then it's going to be 4v. They're going to say it's going to go 4 times the velocity. But you have to think a little bit more in depth, okay? So you have to, for this equation, for this problem, the best equation to use is this equation. The final velocity of an object squared is equal to the initial velocity of the object squared plus 2 times acceleration times d. Okay? This equation applies when an object accelerates at a constant rate. So, if the initial velocity in both cases was 0, which it was in this case, the initial velocity is 0, so the final velocity in this case, we'll call this v and then we'll call this v prime. So the v final and v final prime. So v final is equal to what? Well, since this is 0, it's just the square root of 2ad. In this problem, the a is not given to us, the d is not given to us. So the only thing we can say is the final velocity here, in this part, is the square root of twice the acceleration times the distance. Well, what's the final velocity here? If you're accelerating 4 times the rate. So the final velocity prime squared is equal to 2ad. This time the acceleration is 4 times a, right? So we can put here a prime. V prime, a prime. So over here put vf prime squared is 2 times what? Well, this is 4 times the acceleration, right? 4a. Now take the square root of both sides. The square root, right? So if I take the square root of this, well, you're still going to have same as here. You see square root of 2ad? There you still have a 2a and a d. But then you have an extra 4. Okay? So basically it's kind of like this mathematically. Square root of 4 times square root of 2ad. Square root of 4 to square root of 2ad. Square root of 4 is 2. Right? So v final prime is equal to 2. There is just square root of 4. Square root of 2ad is what? Vf. Right? So the final velocity here is only twice the final velocity here, even though the acceleration was 4 times as much. Okay? So the answer is A. Now some might argue, why is that? Why? If you go 4 times acceleration, shouldn't you have 4 times the velocity? Why is it only twice the velocity? The answer is this. If you're going at 4 times the acceleration for the same distance, it's going to take you less time. That means you haven't been accelerating as long in this case as you have been accelerating here. So your time has been cut. And therefore, your final velocity here is not 4 times as much. Okay? The next question, which I'm going to do later, you will see that it's related to this. And your questions might be answered when you see the solution of that one also. Okay, thank you.